Okay, question 5. A man 6 feet tall walks at a rate of 5 feet per second toward a street light that is 16 feet above the ground. At what rate is the length of his shadow changing when he is 10 feet from the base of the light? Goodness gracious, how are we ever going to find this out? Well, little bit by little bit, let's look at this. Let's draw a picture. And when you think about the things, the players that we definitely have a street light that is 16 feet tall and not changing. And we definitely have a man who is 6 feet tall, right? We definitely have the ground, right? The man is 6 feet tall, and he's not growing either. At a certain point, you stop growing. And let's see, we know he's walking at a rate of 5 feet per second. So that's a rate of change. So here's the guy. Here's the street light. This is what's changing. So I'm going to call that x. And I know that dx dt is going to be negative 5 feet per second because x is shrinking. So we know that. And we're wondering about the length of his shadow. Well, here's the street light hitting the guy. His shadow is going to be right down here, so I'm going to call that y. Y is the length of his shadow. And we're looking for dy dt equals question mark when he is 10 feet from the base of the light, so when x is equal to 10. Okay, so we need to find a relationship between these rates of change. We need to start with a static relationship. So one thing we can say over here is that we have similar triangles. So I know that if the triangles are similar, their sides are in proportion. So I'm going to say the ratio between 6 and 16, little triangle to big side to big triangle, equals a side of the little triangle y to a side of the big triangle, which is x plus y. Okay, I'll simplify to make my life a little bit easier. I'm going to cross multiply. So 8y equals 3x plus 3y. So 5y is equal to 3x. And there's my static relationship. Now let's introduce rates of change. If this is the relationship between x and y, then it's also going to be true that 5 times dy dt is 3 times dx dt. And now we can just plug in what we know. We know dx dt is negative 5. Right, in fact, that's going to be negative 15 feet per second. And if I divide both sides by 5, dy dt is negative 3 feet per second. So his shadow is getting shorter as he walks towards the light.